Hello guys, welcome to my YouTube channel. This is the first video of my channel as well as the first video on the tutorial series on core Java. So let's start. The first question that would strike one's mind would be what Java is. So Java is a platform independent and object oriented programming language which provides developers with the means to create powerful applications which are very small in size, secure and robust. So where Java can be used? Java can be used in creating desktop applications using swings, AWTs, JDBC and collection APIs. Also several APIs such as Java Mail, iText and JFreeChat can extend the basic functionalities of the language itself. Web-based applications can also be created using servlets, JSPs, struts, Hibernate, etc. And the Android platform also uses a customized version of Java as its programming language. Enterprise applications can also be created using Java technologies such as EJB, RMI, Spring, Grails framework, etc. So the next question would be why Java when there were so many languages like C and C++ before Java? So the answer would be that these languages were dependent on the platform on which these languages were compiled and were supposed to run. Let's take this example. Suppose you are a developer and you are creating a program. You created the program in C++. And this is the source code of your program, and this single program is supposed to run on 5 different machines that have different operating systems installed on them. So how would you achieve this? You would compile this source code on these 5 different machines individually, and then only it can run on these 5 different machines. So the source code written in C++ would not be platform independent. Now suppose that this source code is written in Java. Because of the architecture of Java virtual machine, you need to compile this source code only once in order to run this on these 5 different machines. How platform independence is achieved in Java is a topic in its own, and I would explain that in a separate video. But to accomplish this goal of being platform independent, the Java runtime system, that is the JRE, has to be compact enough so that it would fit on these different systems. What initially happened that Java was thought to be a technology for embedded devices and not for the desktop computers. Microprocessors has been appearing in device like cell phones, printer and fax machines in the 90s, and with the advent of graphical web browsers like Mosaic, the next trend would be that the embedded microprocessors would be connected to a network. So an original design goal of Java was to provide a way for software to be delivered across networks to any kind of embedded device independent of its microprocessor and the operating system installed. And the embedded systems always have a constraint of the memory on which they are running. So the JRE need to be compact enough to fit on the RAM of these different embedded systems themselves. The next part would be features of the programming language. As it's an object-oriented programming language, it supports encapsulation, polymorphism, inheritance, and abstraction. I won't be going into the details as there are many good videos on YouTube explaining these topics. If you are not familiar with them, I would recommend watching them. I would discuss language-specific features instead. Java has some methods in the java.lang.character class that are useful in internationalization of Java applications. These methods can tell if a given character is a letter, number, space across different languages. In C language, if you have to find if the character is a letter, number, space, etc., you would simply compare it with its ASCII value. And here's the ASCII chart. Like for example, if you have to find out if the number is an uppercase number, you would just simply use an if statement, that if the number is between 65 and 90, then it's an uppercase number. But things are not like this in Java, which uses the Unicode character. You can confirm it by viewing the source code for the character class. For that, go to Program Files, Java, JDK, and this src.zip is the zip file for the source code of your current distribution of JDK. You have to extract it. I have already done it, so I'm just going to open it. Go to src, go to java.lang. Java.lang is the package and character is the class itself. Here you can see I have opened the character class and I have opened the implementation of the is lowercase method of the character class, which takes as input character, and internally what is happening, that it is calling the same function but with an integer argument. So we'll go to the implementation of that function instead. So is lowercase with an integer argument is specified here. So why use Unicode instead of ASCII? The first reason would be internationalization. That is, Java is supposed to run on internet itself, and internet has to support many different languages which won't fit into the range of ASCII. So Unicode has to be used. And secondly, for example, suppose as a programmer you have to write a program which outputs if the given character is a lowercase character or not. You could not do that simply as you would do with an ASCII chart, that if the number is between this and this, it would be a lowercase character, as Unicode supports many different languages, each having their own lowercase letters. So this function is lowercase provides a standard interface to do the job, and in this way the whole class, character class itself, facilitates internationalization of Java language. Another feature would be that not just the architecture of the language and the JVM, but the Java language itself supports the platform independence of the language. Like for example, if I type int a in Java, it would be 4 bytes no matter on which machine I am running this program. But in languages like C and C++, the size of the integer depends on the machine as well. So the programs written in C and C++ cannot be easily exported to different languages because of this constraint of the size of the integer itself. But in Java, the size of the integer will always be 4 bytes no matter on which machine this program is running. So this also facilitates in the platform independent nature of the language itself. Finally, Java is not a pure object-oriented programming language. The 7 properties of a pure object-oriented programming language would be encapsulation, inheritance, polymorphism, abstraction. All predefined types are objects. All operations that are performed on these objects are by passing messages between these objects, and the user-defined types themselves are also supposed to be the objects. So because of the presence of primitive types in Java, Java is not a purely object-oriented programming language. Let us again take the example of the integer. I'm initializing it and then I'm printing its value. So it would return 10. This statement is just printing the value of a. So it would simply print 10. And if I try to use any method on this, it'll just give me an error that cannot invoke toString on the primitive type int. So the language itself specifies that methods like these cannot be applied onto an integer data type, signifying that this integer is being treated as a primitive data type and not as an object, but primitives are still kept in the language for performance reasons. Some examples of pure object-oriented languages would be Ruby and Smalltalk. Well, that is all for this introductory tutorial for the Java language. Hope to see you in the next video.